All right. Hello, everyone. Welcome to episode 139 of YFTT, Talks by Engineers for Engineers. I'm Mihnea from our engineering team, and I'm joined by Sushant, who's leading, well, a number of projects in our SQL area, including the very exciting project we're going to talk about today. So, Sushant, I'm going to let you introduce yourself and topic for today. So, please go ahead.
Thank you very much, Meghna. Hi, my name is Sushant Mishra. I'm a part of the LRT team at YugabyteDB. I've been with Yugabyte now almost around 4 years. So today we are here to talk about the Postgres 15 compatible YSQL. So just a little bit of a background. We started this project around 2 years ago. And in order to upgrade YSQL, we started with Postgres 11. And in order to upgrade to Postgres 15, when we merged with the Postgres 15, we found like there are approximately 2 million lines changed across 6,000 files. So obviously it was not an easy merge for us. But due to the team's incredible effort, like we managed to launch YSQL, which is now Postgres 15 compatible with 2.25.0 release. Previously, last year of May, we provided a sneak peek and updates where we are in that journey and just talked about many of the features. The QR code links to that previous YFTT talk. So just reiterating the point that YSQL is now Postgres 15 compatible with 2.25 release. It has tons of new features, tons of new optimizations. And today we will cover some of those features. There are many more in the list. Some of the other ones are also referenced later in the slides as a summary. Please engage us on the our community Slack channels if you have further questions about YSQL with Postgres 15. So without further delay, I would kind of really like to dive deep into the individual features which we have enabled in Postgres 15. One key bit with these features is these features are just not the import of like what is supported in Postgres 15, but they are highly optimized for execution to give an optimal performance on a highly available and distributed architecture of YugabyteDB. So it started with the first feature, stored generated columns. So a stored generated column is a column which stores the computed value based on the other columns. And whenever the other dependent columns are updated, the column values are recalculated. So for example, if we have a customer table which has two columns, first name and last name, we also have a full name, which is a stored generated column indicated by this keyword generated always as, which is a concatenation of first name and the last name together. And a stored keyword just indicates that this is the column is actually stored on the disk. For this particular feature, in the YSQL, we have also optimized to skip the index write if the generated column values are not really updated. So for example, we can have an index on the full name, but if any of the dependent columns such as first name and last name is not updated, then we will also skip the index write to the full name. And that helps improve the performance because this update is redundant, those columns are not really changing. And that really helps with, especially in the Yugabyte distributed architecture, minimize the number of operations we have to really do. So let's see within an example like what the generated columns look like and how does YugabyteDB has optimized it. So before I kind of really go to that, I would like to describe the schema which I will be using in my demo today. So we have a customers table where customer ID is the primary key. And full name, as I described earlier, is a generated column, which is a concatenation of the first and the last name. And we also have an index on the full name, which is basically the generated column. Now, there are many other fields in the this customer table. They are just kind of keeping track of like various details of the customers. We also have a unique index on the customers, which is a combination of the column of email and the phone number. And I will talk in more detail about this particular index in subsequent slides. So with that, I'll go over the demo for the generated columns. So so in this particular customer tables, I have already preloaded the randomly generated data. This customer tables has around 5,000 rows. I randomly selected one of the rows. So in this case, we observe that the first name is Louis, the last name is Watts, and the full name is automatically generated, which is Louis Watts, as it was a combination of the first and the last name. Now, what we will do is we will update the last name to Watts underscore new. And so we are also updating one another column named email to a different random email for the same particular row, which is displayed on the screen. So let's see how this execution looks like. I'll come to the details of this execution in a bit, but let's just check if the rows are actually updated. So you see, if you observe here, the last name is updated to Watts underscore new, and the email is also updated. One key point here is the full name is also updated with the new last name now. So this is the power of generated column. The dependent columns are automatically updated whenever you update now. Just for one more key bit here to show the YugabyteDB optimization, I'll execute the same update query again, where the last name is updated to the same values where what they were previously set to. So last name is updated to Watts underscore new, and that's already exists. And the same thing for the email as well. I'll execute this at this point. If you observe in this particular explain analyze plan, you will observe that the storage table write request shows as 1, but there are no writes to the indexes here. Versus in the previous update, we have the write request to the indexes as well. The reason being, since these column values are not changing, we skip the writing to those particular indexes which are on those corresponding columns. And this helps reduce the number of writes as well as the number of total write requests between the Postgres and our storage layer, and kind of helps improve the performance of the query. So that was all on the store generated columns.
Yeah. So one thing I want to add there is that it may have seen like an artificial example, but it's actually as Sushant is well aware, is a surprisingly common pattern by various tools or ORMs and so on to generate updates even for columns that are not really changed because of the pattern in which the code is written. So that case, or similar cases, actually come up quite often in practice.
Yeah, good point, Mihnea. Thanks for mentioning that. So now we will go to the second feature, foreign key referencing the partition tables. So with the YSQL, now when it is updated with the Postgres 15, you can create a partition table. For example, as shown in the slide, there is an orders tables, which is partitioned by range. And you can add a constraint, the foreign key constraint, which is referencing another customer's table. What happens by doing this, each partition of the orders tables will automatically inherit this foreign key. Previously, this was not possible. Rather, it required that one needs to create the foreign keys on each individual partition. Now, with the YSQL, we have also optimized this feature for efficient execution by batching the foreign key checks for the reference table. Let me go to uh, the demo for this one. Yeah. So I'll select a particular row from the table. Actually, before I select the row, let's kind of also take a look at the schema for the orders table, which we haven't really gone through yet. So orders table has an order ID and a customer ID. And this customer ID, so basically the constraint is every time we insert a row into the orders table, we should make sure the customer ID is valid and should exist in the customer table. And that is achieved by creating a foreign key reference here to the customers table. And this table is also partitioned by range, order time. And currently in this particular demo setup, we have created one partition for each month of year 2024. So there are total 12 partitions. With that, I'll kind of just switch to the demo of actual use case here. So I'm selecting a random row from the orders table. This orders tables is also populated with various randomly generated orders. And we will try to update the customer ID to an ID for which the corresponding customer ID does not exist in the customer tables. My apologies, the wrong copy paste. So we are updating the customer ID here, but this customer ID does not exist in the customer tables. Hence, we get a foreign key violation. So this is very powerful that we can just create the foreign keys on the partition table and not have to really worry about as all the other partitions inherit that. The next bit I would like to call out is the YugabyteDB optimization, specifically around the foreign keys execution and by batching the foreign keys together. So for that, let's take another example of inserting multiple new rows into the orders table. So for example, in this particular example, we are inserting 3 rows. This is the first row, and this is the second row. One thing to observe between the first and the second row, this is the customer ID, starting from A4D3. And similarly, in the second row, we have the same customer ID. So basically what is happening is for a particular customer, we are adding 2 orders in the orders table. For the third row, we have a different customer ID. So essentially, again, just reiterating that we are inserting 3 rows, 2 for one particular customers and 1 for a different customers. Before I execute this query, I just wanted to point out that in this particular case, we expect 3 foreign key checks to happen since there are 3 inserts. So we insert this row. The YSQL engine should make sure that this particular customer ID exists in the customers table. And again, it is the same for the second and the third row. But since these customer IDs are the same, it's redundant to check them twice. We can only, as long as we check them once that the customer ID exists, that is really sufficient. So YSQL have been optimized with this optimization where it removes the duplicates and minimizes the work that way. So basically 3 foreign key checks in this case are reduced to 2. I will execute the query. So since you are inserting the 3 rows, so there are 3 write requests are performed here. The next bit is why there are 2 rows scanned. So for a foreign key check, you have to really read the row in the customer tables. As I mentioned earlier, for the 3 rows, Instead of performing 3 checks, we are only doing 2 and removing the redundant check. So that's where the row scans are 2. One another optimization in the YSQL we have is to batch all the foreign key check requests together. Basically, both the foreign key checks are sent in the same request, and they are executed parallelly for the optimal performance. Hence, the number of read requests is only 1 here. So just to kind of recap, 3 writes, we optimize the foreign key checks and removed one of them. So there are only 2 foreign key checks done, and they are kind of bashed together and sent in a single request.
Very nice. This is a very nice example that also shows how our extensions to explain analyze also can be used to understand what's happening under the hood. So obviously the optimization itself, but nice to see kind of the distributed um, um, option kind of showing exactly what's happening.
Absolutely. Yes. Yeah. Moving to the next feature. So whenever we create a unique index on a specific column, and that column can have multiple null values, and they are all by default are treated as distinct. Basically, the unique index can contain multiple null values in a column. Now, with Postgres 15, there's a newer syntax where you can create the unique index with null not distinct. So, which implies that you can at most have one set of nulls, but not more than one, as nulls are not treated as a distinct anymore. This is also optimized in the YSQL. If the unique index is used in the insert on conflict clause, then we perform the batching to kind of do the efficient execution. Now, we will observe this in a demo, like how does batching looks like and how does it help us to perform the efficient execution. So one caveat I just wanted to call out, this optimization does not work in 2.25.0 release when the foreign keys are present on the table, but that will be available for the foreign keys as well in the upcoming 2.25.1 release. So just to avoid that constraint, what I have done is I've created another table which is same replica of which is the same replica of the customers tables. And I will be performing inserts in that particular table. So give me 1 second. I'm just copy pasting the rows here in the table. So in this particular case, I am inserting 4 different rows in the table, in the customers table, and it has an on conflict clause on the email and the phone number. So let's go through the schema for a bit here. For the customers table, we created a unique index on the combination of email and the phone number, and this index was created with null not distinct. So in this particular query for the conflict resolution, the index which is on the combination of email and phone number will be used. So if I execute this query, it ends up inserting 4 tuples because these 4 rows did not really existed before. Key point here is, and I'll explain that in a little bit, the number of read requests is 1 here, and the number of total flush requests is also 1. And this is because we have done the optimization to perform the insert on conflict batching.
So just to understand, so what's happening here is that we are essentially writing 12 rows because it's the main table and two secondary indexes. But all those rows we can figure out ahead of time and send in just one batch, one flash request. That's why the flash request is one. Is that correct?
Yeah, that is correct. Thanks, Meghna, for clarifying this. Right? So currently, insert on conflict batch size is set to 1024. So that's where all the rows are read up front and then kind of flushed together. If I set the insert on, so let me also execute this query with the batching disabled and see how that execution really looks like. One point to note here is with the batching enabled, execution time took 7 milliseconds. And we will execute exactly the same query again. And the execution time from 6 milliseconds has gone to 15 milliseconds. And the reason being, the number of storage index requests used to be 1. Now they are 4. And similarly, the flush requests are 4. Basically, we are making 4 round trips between the Postgres and the storage layer. And that is without the batching. But once the batching is enabled, these numbers become 1, each of these. And also, which results in an efficient execution where the query was completed in approximately 7 milliseconds. Now, you can also imagine, in this case, I'm only inserting 4 rows, but as, let's say, if the insert on conflict clause is inserting 100 rows, the performance gains are even much, much higher. So moving on to the next feature, inline CTE evaluation. Excuse me. So a CTE case, what happens is the CTE, the query in the CTE clause, which is select star from foo, here is evaluated only once for execution. With the inlining, what happens is if the CTE clause only referenced once, then the select star from foo can be folded together with the parent query. Now, for example, if you look at it, what happens here is select star from foo collects all the rows from the table. Let's say if the table foo has 1,000 rows, and it will collect all the 1,000 rows, and then it will apply that filter on that output to key equal to 1, basically returning the specific rows which matches this criteria. Same query can be written in a different form where we say select star from foo where key is equal to $1. Now, if the CT is written like that, Postgres automatically identifies this pattern and does this optimization of folding the queries together for a more optimal performance. Let's see this with an example here. So this optimization, as I mentioned, is only available starting with Postgres 15. So in this particular CTE query, in the with clause, the CTE which is specified, what is calculating is the total money spent by the customer on all of its orders together. And this is calculated for each of the customers. So for example, if a customer has $10 and each order costs $15, the total sum will be $150 for that customer. And that is calculated for each of the customer. And once we have that result set, then the result set is filtered out only for these two particular customers. The materialize keyword is specified that this CTE should not be folded. Basically, that optimization we just talked about is disabled with this query. Once I execute this particular query, then you will observe this query takes around 2 seconds to really run as it scans the whole customers and orders table and prepares the data set. And finally, the filtering out really happens. Uh, if I execute the same query without the uh, materialize keyword, that is allowing the optimization which we have in YSQL, which is Postgres 15 compatible, this query just takes 10 milliseconds to execute. As this query gets executed, as it is a simple join between customer and order status and filtering out the results using index scan for those only for those specific customers, because the result set of the rest of the customers is anyways discarded away. So this is a very powerful optimization, as you see, that reduces the time from like 2 seconds to like 10 milliseconds in this particular case. Uh, uh, with Postgres 15, there are more new functions has been introduced. The utility functions which helps application code simpler. One of the key function is the generating the random UUID. Previously, users has to use the UUID OSPP extension. This provides function to generate UUID, but now this is a natively inbuilt. And if you also observe that in the our schema, we have uh, been using this particular function to generate the customer ID and the order ID, which was not possible previously with the Postgres 11 based YB. Similarly, with YSQL, which is Postgres 15 compatible, we have many new regex related utility functions, which kind of really allows better parsing uh, and kind of let applications write the code for better aggregation and kind of really search for various different patterns. Just quickly going over those functions, the regex xp count kind of really just searches for like how many times a particular string appears in a particular pattern. Regex exp underscore en instruction finds like the for a particular pattern, what is the first location it is really like the pattern which we want to search, what is the first location we find in a given input. The next one, the regex expression like just checks whether the pattern really exists. Even sometimes we just want a true and false answer whether the pattern exists. And the last one, the regex expression underscore substring, it kind of really matches the nth occurrence of the pattern. So basically, in this case, we want to search for pi and we want the second occurrence of it. So it kind of really be returning the second occurrence here. These are again interesting utility functions which can be utilized by the applications to modernize their workload. Going over the next feature, we have the planning time tracking. So the very first time when the query gets executed, during the planning phase, the query planner tries to figure out what tables are being accessed, what are the different kind of columns are there, and for that it requires access the system catalog objects. Now, YSQL is optimized to cache and preload the system objects, but in the first execution, it still has to really access some of those objects directly from the Postgres system catalog. And in a distributed architecture of YugabyteDB, this could be a significant time. With the enhancement in the PG start statement, the tracking, like how much time is spent, like becomes much easier. So we have these columns: total plan time, minimum plan time, max plan time, and the mean plan time, which tracks like various metrics associated with the planning time. And that kind of really helps optimize like how much preloading we need to do for these particular object and how much caching is really required. Uh, as we just covered like some of the few of the features, and previously sneak peek also covered some of the features, but Postgres 15 has many more features. Some of them are like listed here: incremental sort, which immensely incremental sort, memoized node, accelerated partition and pruning. These are like improve the query performance for various specific queries in specific scenarios greatly. Disk-based aggregation really helps with the limiting the memory utilization of the query by spilling to the disk. if the hash aggregation is used. The other features, copy from with where clause before row trigger, multi-range and range aggregate types, create or replace trigger, fetch first size. These are like good usability features which really help application write more. Excuse me. Which helps application write like easier code or do even more in their application and the ability to rely more on the database. Beyond that, we have many more security enhancements and many more features which are coming with the YSQL, which is Postgres 15 compatible. So this concludes our talk for today. Please start us in the GitHub and join our Slack channel. Both of them are linked on this particular page. Thank you.
Yeah, thank you, Sushant. That was fantastic. And yeah, like you said, this was a small list of the many features that are coming up in our recently released first PG15 based preview release. And yeah, I think on the previous slide you had a list of even more features. Some of them were covered. I believe it was YFTT episode 111 in our sneak preview. I think incremental sort, memoize node, and disk-based hash aggregation, I remember, were covered in that previous talk. So if folks are interested in more of a deep dive into those, and of course Sushant covered a lot more today. And I also liked, so I think this shows some of the work that we have to do. So because we reuse the Postgres code base, we get a lot of these features as part of rebasing and picking up the upstream changes. But for each of the features, we go through this analysis of what do we need to do to make sure they can run efficiently in a scalable and resilient distributed database. And Sushant gave the example with the round trips, with the batching, like in circumconflict and so on, that we've done for all of them. So yeah, really amazing work. And yeah, let's see if there's any additional questions. So we'll wait just maybe one more minute. Anything else you wanted to add before we close it?
Yeah, please try out the YSQL release 2.25.0 and provide us the feedback. If you find any of the features missing or any of the issues you are facing with, please connect us on the community Slack of YugabyteDB and provide us feedback there or in our GitHub issues. We are always looking to hear more from our users and the customers and looking ways to kind of really keep improving. Hopefully some of these features are exciting and kind of really helps better results in the better applications as well, and allows more applications to even run on the YugabyteDB. But we definitely welcome more engagement and feedback, if any, in that regard.
Excellent. Yeah, I was going to say the same. Please try out the release. So it's out now for a week or so. And yeah, any questions about, or any issues or anything from trying, please reach out on either our Slack channel or our GitHub. So yeah, thanks again, Sushant, for an excellent talk. Thanks everyone for joining. Have a great day.
Thank you. Thank you very much.